History of Earth and Space Science. We are on our second half of the unit. This is going to be lesson 4 of dangerous compounds. So our objectives for this video, which may turn out to be two, is to define what chemical bonding is and describe why bonds form. We mentioned that already. Explain how covalent bonds form, write a covalent compound's name, and to be able to write a formula for a covalent compound from its name. So in the lesson 3 video, we mentioned that there are 3 types of bonding. There's ionic, covalent, and metallic. We will not be doing anything with metallic. It's touched on very briefly in AP Chem, but we will focus. Lesson 3 was all about ionic, and lesson 4 will be all about covalent. So what is a covalent bond? Well, the difference between a covalent bond and an ionic bond is in an ionic bond, the electron will physically transfer from one atom to another. It's usually the metal atom will lose electron and give it to the non-metal or the polyatomic ion. So you have a complete exchange of the electrons between one atom to the other. Whereas in covalent bonding, we share. Okay, the electrons will share between two atoms as part of a chemical bond, and that chemical bond is a covalent bond. Co meaning shared valence shells. The valence electrons will be shared between two of them. Now, everybody needs a full octet. It's called the octet rule, meaning it needs 8 electrons to surround it to look just like a noble gas. The only exception is hydrogen, because hydrogen only has in its first shell only 2 electrons, so it needs to get up to only 2. But every other element on the periodic table needs to get up to 8. So when we're dealing with covalent bonding, we're only talking about the valence electrons, so we're not dealing with any of the inner electrons, just like we didn't deal with them in ionic bonding. We're dealing only with the valence electrons, and in general, the ones that get paired up are more stable than the ones that are not. So we're going to try to fill in those electrons, those spots around the atom, to try to make it full. So when 2 atoms share the electrons, the covalent bond is formed. We use what are called Lewis structures to try to represent or show how that structure forms, and we're going to go through quite a few examples here. And kind of walk through how to determine or how to draw a Lewis structure. So what is a Lewis structure? Let me draw one real fast. A Lewis structure here, and I'm going to just put it on this thing and I'll erase it, would look like this. So you'd have pen. You might have something that looked like water. So hydrogen, electron, electron, oxygen, electron, 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 then hydrogen. And this hydrogen has a full shell, meaning it has 2. This hydrogen has a full shell, it has 2, and the oxygen has a full shell because it has 8. So if I were to draw it with the lines, it'd be H, line, O, line, H, where the lines represent a covalent bond. Okay, so let me get rid of that, and we're going to talk about how to draw a covalent bond. Okay, so first thing you want to do is, based on whatever your molecule is, first you need to count up all the total valence electrons. What that would mean is taking every single atom that's in the compound, figuring out for every single atom how many valence electrons there are, and then adding them up. Second, we draw a skeleton structure, trying to establish what the molecule might look like, and normally it's very clear what the central atom is going to be and what's going to surround it. And then we're going to make sure there is a bond between each of the adjacent atoms, each being a pair of electrons. Then we're going to assign whatever electrons we have left over to the outermost or the substituent atoms that are around the outside, making sure everybody gets up to 8, except for hydrogen needs to get up to 2. And then finally, if there's not enough electrons to make the central atom is there not enough electrons for the central atom to get a full octet, then we're going to use multiple bonds to try to complete those octets. So let's talk about the simpler one first, just the straight up single bonds. So here's an example. So carbon has four valence electrons, and fluorine has 7. So 7 times 4 is 28. So we have 32 electrons to work with. That's my total valence electrons. So looking at how it's structured, almost always, unless I tell you otherwise, the first atom is going to be the one in the middle. So what this looks like is a carbon and surrounded by 4 fluorines. So there's my skeleton structure. Now I got to make sure I have the bonds. So between each pair of electrons, I'm going to draw a pair of dots. Between that carbon and fluorine, between this carbon and fluorine, between this carbon and fluorine, and between this carbon and fluorine. I have 2 dots. So now I've used 8 dots. So now I'm down to 24. Every single one of those dots represents a valence electron. So now I'm going to go ahead and take the remaining electrons I have, and I'm going to fill up the substituents, the ones on the outside, to get up to 8. So let's start at the top. 1, 2, 3, 4, 5, 6. Now that's full, right? It's got 8 around it. 1, 2, 3, 4, 5, 6. Now that's got 8 around it. It says 12 I've used. 13, 14, 15, 16, 17, 18. That was full. 19, 20, 21, 22, 23, and 24. And that one's full. And I've used up all my electrons. So what do I have? I have this one's full. I have this one's full. I have this one's full. It should be on the outside of the circle. And then this one's full. I'll be more careful here. And then at the same time, my carbon in the middle also has 8 electrons around it. And this would be the Lewis structure for carbon tetrafluoride. Let's do a couple more. Next one. Nitrogen trihydride. So I have nitrogen. Nitrogen has, where's my dot? Nitrogen has 5 valence electrons. And hydrogen has 1, but I have 3 of them. So I have a total of 8 electrons to work with. Okay, so I'm going to put my nitrogen in front because it's listed first. Nitrogen in front. My hydrogen is around it. 1, 2. And it really doesn't matter which side you do it on. I just happen to choose to start on the top. And then now I have to make the bonds between the adjacent atoms. So that bond, bond, bond. So I've used 6, so I have 2 left over. But check this out. Right now, this one is a full duet because hydrogen only needs to go up to 2. This one's a full duet, only needs to go up to 2. This one's a full duet, only needs to go up to 2. That nitrogen only has 6 around it. It needs 2 more. So this last 2 electrons go over here, and voila, nitrogen is also a full shell. So this would be the Lewis structure for nitrogen trihydride. Another one. Water. Well, we've done this a lot, so it should be pretty easy, but let's start with this thing. Hydrogen, that has 1 times the 2. Oxygen, that has 6. So again, we have a total of 8 to work with. And we know that oxygen is going to be the one in the middle, just our common knowledge. And the hydrogen is going to be outside. So we got to put our bonds in. 1, 2, 3, 4. So I've used 4 of them up. This hydrogen has a full shell. This hydrogen has a full shell. The oxygen in the middle only has 4, but I have 4 more electrons, so I can do 1, 2, 3, 4, and now water is complete. This is the structural formula for water. So you start by picking which atom goes in the middle, surround it by the letters that represent the symbols for the atoms that are also in the compound. Make your bonds, and then fill up the outside shells, and then with whatever you have left goes on the inside atom, the central atom, and maybe that'll be enough. If it's not enough, we need to do double bonds or triple bonds. Oh, one more. So this one's kind of tricky. Let's do the numbers first. Carbon has 4, so carbon has 2 times 4, or 8. Hydrogen has 1, so I have 6 times 1, 4, 6. I have 14 electrons to work with. Now, for this I would tell you, but the carbons are next to one another in the middle, then the hydrogen is kind of surrounded. I would give you a little better indication of which atoms are around what on this, but it is how it looks. So let's go ahead and use our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've used up all my electrons. And lo and behold, everybody's happy. I've got this atom has 2, this atom has 2, this atom has 2, this atom has 8, this carbon has 8, this atom of hydrogen has 2, this atom of hydrogen has 2, this atom of hydrogen has 2. So this is a structural formula for C2H6 or dicarbon hexahydride. Okay, so those are some examples that just have all single bonds. What about these multiple bonds? Well, multiple bond is when you have more than one pair of electrons. So when we did this, every single pair of electrons, this was a single bond, because it's only one pair. But I have multiple pairs of electrons, they only come in pairs, then I'm going to have a multiple bond, either a double bond where I have 2 pairs, or a triple bond where I have 3 pairs. So when the 2 atoms share and they have 2 pairs of electrons, or a total of 4, that's called a double bond. And if the 2 atoms that share have a total of 3 pairs, that's going to be a triple bond. And quadruple bond is not possible. Come to AP Chem to understand why that's the case. So if I had to draw a classic atom that has a double bond, that would be oxygen. Oxygen has 2 oxygens, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in order for oxygen, which means oxygen has 2 atoms times 6, has 12 electrons, it would have to have a double bond in between them. So this oxygen would have 8 around it, and this oxygen would have 8 around it. This is a double bond. Because I have 2 pairs of electrons. Okay, let's try some. CH2O. Let's get our tally. Carbon has 4. Hydrogen has 1, but it's 2 atoms. And oxygen has 6. So 4 plus 6 plus 2 is 12 electrons. So this is what we got. The carbon is going to be in the middle. Hydrogens are going to be on 2 of the spots. And the oxygen is going to be elsewhere. First things first, make the bonds. 1, 2, 3, 4, 5, 6. So we've used 6 of the 12 electrons. We have 6 left. Now we need to fill up the outside. Well, let's start here. This right here is already good, and so is this. So let's fill up the top one. 1, 2, 3, 4, 5, 6. Now this one's good. You see that? But poor sad carbon in the middle, it does not have enough. So what carbon's going to do is we're going to take, let's see if we can get it. We're going to take these 2 electrons. Let's see, I'll do a different color. Yeah. So I'm going to take 2 electrons that are already on oxygen, and I'm going to move them. I'm going to move them and put them between the oxygen and the carbon. Now, the carbon has rounded by 8. I didn't take those 2 yellow ones out of the oxygen circle. I just moved where they're located. So what I have here is a hydrogen, a single bond, a carbon, a single bond, hydrogen, and a double bond to an oxygen. That would be the Lewis structure for this compound is called formaldehyde. Next, C2H4. So let's do this. Carbon has 4, so 4 times 2, 8 electrons. Hydrogen has 1, but there's 4, so that's 4 electrons. I have a total of 12 electrons to work with. So let's start by doing it similar to the C2H6 we had before. Carbon, carbon, hydrogen, 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 hydrogen. Let's start filling in our dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've used 10 of them. I have 2 left over. Now I have a problem. If I take these 2 electrons, let's say I take these 2 electrons and I put them, say I put them here. Say I put them right here. Well, now this carbon is good, right? This hydrogen is good. This hydrogen is good. This hydrogen is good. This hydrogen is good. But lo and behold, this carbon over here is not. So what I'm going to take is these 2 electrons I added last, and remove them, and I'll put them in between the 2. It's still in the blue circle for this carbon, but now I can be in the circle for this carbon. And this is the structure for what's called ethene. It looks like this: carbon, double bond, carbon, H, 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 and H. That's ethene. This bond here is a double bond. Okay, let's keep going. Next, C2Cl2. So carbon again. Carbon has 4, and there's 2. So that's going to be 8. Chlorine has 7, and that's going to be 2, which means I got 14. So I have a total of 22 to work with. Okay, so let's try this. Carbon, carbon. Chlorine, chlorine. Got a little premature here, so I'm going to get rid of this over here and get rid of the dot. Okay. Okay. Now I need to put in my dots. So first things I do is put the ones between them. 1, 2, 1, 2, 1, 2. So I've used 6. So I have 26. Oh, sorry, 16 left over. Let's make the outside ones full. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've used 12. So now I have 4 left over. And unfortunately, these ones in the middle. So this one's good. This one's good. But the carbons in the middle is not so good, unless, of course, I take those remaining 4 and I make those be all in the middle. 1, 2, 3, 4. So these are these 4. I make them in the middle. Now look, this carbon has 8 around it. This carbon has 8 around it. Everybody's happy. We have a full, complete structural formula. It'd be chlorine, bond, carbon, triple bond, carbon, single bond, chlorine. This is a triple bond. Okay, let's keep moving. One point to be made is up until this point, we talked about different types of bonds and such. And one thing that maybe wasn't as obvious is when we were talking about polyatomic ions are actually held together by covalent bonds, and overall they have a charge. So for instance, sulfate has made up of sulfur and oxygen. Covalent bonds are usually between nonmetals, and sulfur and oxygen are nonmetals. And if I had to draw the structure for this, this here tells me that I have an extra 2 electrons. It's a -2. So sulfur has 6. Oxygen also has 6, but there's 4 of them. So at this point, I have 24 plus 6, or 30 electrons, plus 2 electrons for the charge. I've got 32 electrons to work with. So let's draw it. I got sulfur, oxygen, 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 oxygen. Let's do my electrons. 1, 2, 3, 4, 5, 6, 7, 8. That took care of the ones that were around. It leaves me at 24. Now I can go ahead and do the others. Let's see if I can do this with pointer option so we get another color. Let's make these go back to blue. So now this remaining 24, I'm going to add here. 1, 2, again to the outside. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. I am out of electrons, but I also have 1, 2, 3, 4, and even 5 atoms that have 8 electrons around the atom. So sulfate is sulfur with an oxygen, with an oxygen, with an oxygen, with an oxygen, and overall has a -2 charge. Try a couple more. Let's look at NH4. Now this means I'm going to lose -1 electron, because the way something becomes positive, it loses electrons. So I'm going to lose electrons here. Nitrogen has 5. Hydrogen has 1 times the 4 atoms. It means I have 9 to work with, -1 electron, which means I only have 8 to work with. Let's lay it out. Nitrogen in the middle, hydrogen surrounding, and then 1, 2, 3, 4, 5, 6, 7, 8. I've used up all my electrons, but full, 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 and full. Everybody has an octet, and the hydrogens have duets. So this ammonia would have the structure of H, N, H, H, H. Sorry about that. And then it has a +1 charge. NO3 nitrate. Nitrate has nitrogen and 3 oxygens, and it has 1 electron. So nitrogen has 5 valence electrons. Oxygen has 6 valence electrons, and there's 3 atoms. That means I have a total of 23 electrons, plus the 1 extra electron for the charge. I have 24 electrons to work with. So let's go. Nitrogen, oxygen, oxygen, oxygen. That's it. So 1, 2, 3, 4, 5, 6. So I got rid of 6. That leaves me with 18. Then I need to take care of the oxygens on the outside. Let's do that with a different color because I want to. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So now I'm down to no electrons. This oxygen, happy. This oxygen, happy. This oxygen, happy. Nitrogen in the middle, not so happy. So what we're going to do is we're going to take 2 electrons, and it doesn't matter from which oxygen, you just have to take it from the oxygen and move them into the middle. Notice I didn't take those 2 red ones out of the yellow circle over here. I just moved them between the nitrogen and the oxygen. So that now I have a full set of 8 around nitrogen. So nitrate, being that it has a -1 charge, is oxygen, single bond nitrogen, single bond oxygen, double bond oxygen, with a total of a -1 charge. So you should be able to draw the structures for various compounds and polyatomic ions. The first page of the homework in the packet for lesson 3 is called Drawing Covalent Compounds. You should be able to do that particular handout after that lesson. I'm going to go ahead and stop this and make a second part to this dealing with how to name covalent compounds. I'll be right back.